Hello friends, and welcome back to my channel. In the last lecture on this, we've discussed about defining the bond order of different species just on the basis of their number of electrons. And that was a very good shortcut that I've given, which really helps students to do questions less than 30 seconds. So today, this video is just an extension of that, where we'll be doing a lot other questions, and we'll be looking at another very important topic, very important topic rather, which is magnetic behavior. And also we'll do some higher order questions like which is asked in JEE and mains and advanced, and also in NEET. So with this, let's begin. So guys, let's start with the very first topic, which is finding stabilities using bond order concept. So how to do that? See, if you remember in the last lecture, which I'll put the video in the description and also in the I button on the top. So see, if you want to find a bond order of any species, it's very easy. What you have to do is find the total number of electrons. Find the total number of electrons, right? It's there in the shortcut. Then if it is coming out to be 14, then the bond order is 3. 13 decreases by 2.5. I'm just revising for those who are new in the channel. 15, 2.5. And as it becomes 16, it will become 2. 17, 1.5. 18, yes, 1, and so on. You can keep decreasing, keep increasing. That's how you can find bond order. This thing is discussed in detail in the previous lecture. But today, it's not going to be about this one. It's going to be a higher version of that. So here, we will be talking about how bond order affects stability. So bond order is proportional to stability. More the bond order, more is the stability. This is the concept. So based on this, we can start doing some problems. So let's begin with the very first question. And this question was asked in previous year, which is 2021-2020 JEE NEET exams. You can check. The question was, arrange the following. In increasing order of stability. So for such question, how to do it? See, the options are H2, H2 plus, and H2 minus. How to do this question? So we can do it by using emoji diagram. So let's see how we can put emoji diagram into use. So first thing first, let's draw the emoji diagram. So as per the emoji diagram, as per the emoji diagram, when we plot energy on the y-axis and atoms on the x-axis, what's the configuration of hydrogen atom? 1s1. So there are 1 electrons present in 1s1, another electron present in 1s1. Now, see, this is energy high, energy low. See, that's energy high and that's energy low. See, low. Now, as you mix them, as you mix both of them, one electron here will become 2, and on top there will be no electrons. So this is called as sigma 1s, and this is called as sigma 1s star. You know this, right? So what is the bond order? Bond order will be, this is called as anti-bonding molecular orbital, and that's called as bonding molecular orbital. So bond order is nothing but number of bonding electrons minus number of anti-bonding electrons by 2. For these questions, I'll give you a shortcut at the end, but first learn the real way of doing it. We should not always run behind shortcuts. Yeah. So shortcut is already mentioned in the last lecture, but this is just an extension because there could be higher grade question asked, higher order question asked. So for such concept, you should know the basics also. So basics would be 2 minus 0 by 2. The bond order is 1. Okay, so we have got it for hydrogen. Let's see how we can do it for H2 plus. Now, H2 plus is made up of 2 atoms, or rather 2 species, H and H plus. So H has 1s1 electron, and H plus has sadly no electron. There is no electrons present, right? So when we draw the energy versus atom diagram, hydrogen atom is fine. He has an electron, right? But H plus and no electron. So 1, 0. Mix them. So as you do it, this energy is high. This energy is low. So see, high, low. So 1, 0. So because there's just one electron. So even if after mixing, We cannot have more than that. So that is sigma 1s. This is sigma 1s star. But sadly, there's no electron. Now find the bond order. So bond order will be bonding minus anti-bonding by 2, which is 0.5. Okay, so we got the bond order as 0.5. But in the previous case, we got as 1. So I already got one stability. H2 is more than H2 plus. Okay, cool. Now let's do it for the other one, which is H2 minus. How to do that? See, same. H has, what is the configuration of H? We just saw it is 1s1. Excellent. And how about H minus? H minus is a configuration of 1s2 because it has gained 1 electron, right? Yeah. So let's draw the diagram. This is hydrogen atom and that is hydride ion. Let them mix to form 2 anti-bonding orbitals. See, one up and one low, as you know, right? So 1 electron here, 2 electrons here. So it will be 2 down, 1 up, because in total there are 3 electrons. Until this becomes fully filled, we cannot go up. As soon as it becomes fully filled, we have to go up. So bond order will be, this is sigma 1s and that's sigma star 1s. What's the bond order? 2 minus 1 by 2. The value comes out to be 0.5 as well. So this is also 0.5. This is all okay. Then what to do now? See, the previous one was 1. See, here the bond order of H2 comes out to be clear 1, right? But this is where the problem gets tricky, right? This is where the problem gets tricky. Here, the bond order is 0.5 and bond order is 0.5. How to do now? So for that only, this question is very important, you know, because of this variation or because of this small twist. So as I told you, if bond order is more or high, stability is also more. Yeah, stability is more. But what if they are same? Then we have to do this. See, if electrons are present, this is the real concept. If electrons are present in anti-bonding, if electrons are present in anti-bonding molecular orbital, if electrons are present in anti-bonding molecular orbital, then what will happen? The species is considered to be unstable. Species is considered to be less stable. This is the concept, to be less stable. That is the main concept. What do you mean anti-bonding? Anything with star, like sigma star, pi star, whatever it is. So if your electrons are present in these star orbitals, that's where the game changes. You know, the molecule becomes unstable. So now look at both the diagrams. This is the time we analyze it properly now. Okay, so let's have a look. Here, see. For this guy, for H2 plus, what do you see? For H2 plus, there is a clear thing that, see, for H2 plus, we can clearly see that electron is present in sigma 1s. There's no electron present in, see, there's no electron present in upper one. This is totally empty, right? But look at this one. What is happening in this case here? See, in this case, what do you see? There's an electron present in sigma star. That's where the game becomes totally changed. Here the electron is present in sigma star, but here there is no electron present here. Here there is electron present in sigma star, which changes the game for us. So we'll write that as electrons are present in sigma 1s star for H2 minus. It becomes less stable. It becomes less stable than H2 plus. Why? Because H2 plus has no electrons here, but H2 minus sadly has an electron here, which is the real game changer. So the answer, stability, will be, the final answer is H2 more than H2 plus, H2 plus more than H2 minus. So this is the right answer. Now, looking at the bond order 0.5, what you would have marked is H2 more than equal to, you could have thought of this answer, right? H2 more than H2 plus equal to H2 minus, but this is wrong, absolutely wrong, because H2 plus H2 minus can never be equal because of this particular factor, that electron present in ABM or not. So what can we conclude from this discussion? We can say that just saying that bond order increases stability, and if the bond order is same, stability is equal, is completely wrong. Now, what is the shortcut? I mean, what do we have to do so many things here? Oh, is there's no shortcut? Yes, there is one. But I'm just calling it for informally. See, if something is negatively charged, then what will happen? There is a chance that it may have electrons. It may have electrons in ABMO. Why? Because if it is negative charge, electrons might have moved in the higher shell. It may have negative charge. Oh, sorry, it may have electrons in ABM. So that is why negative charge species are typically less stable than positive charge species. But again, I mean, don't go always with this, but it works for most of the times. So there's one question which you can consider doing, okay, which will, help you to do it. So arrange the following in increasing order of stability. This was also asked in previous year paper. Li2, Li2 plus 1, Li2 minus 1. So I'll give you 10 seconds time to do it. Can you do it? Yes, you can. You can do it in the long way by taking 2 minutes time, but this would be a JE problem. But in case, this question comes neat and you don't have so much of time to do it, how do you do this question? So please pause the video and do it the way I have discussed here. The way I have told you, like you have to draw the diagram and everything. So please do it. Pause the video, solve it. So I hope you have tried doing it. So let's discuss the answer. So answer is Li2 more than Li2 plus, Li2 plus more than Li2 minus. How exactly do we do it? Same. Draw the diagram. In this case, in these two cases, bond order comes out to be equal. But since this probably will not have electrons in ABMO, it has more stability than the other guy. That is how we can solve this question. You can also do it in a detailed way by drawing all these structures. But this is the concept. The concept still remains the same. So this is our main concept. Let me highlight it, yeah? This is our main concept. This is the main concept. See? That if electrons are present in ABMO, the species is considered to be less stable than if it is present in BMO. So with this, we are done with higher order questions of BMO and ABMO. Okay. Now, if you want to see the detailed explanation of this one, I can just draw one for you. Yeah. Like for example, let me draw for Li2 plus 1. So what is lithium's configuration? I may need a fresh page. So let's do it. The detailed descriptive answer would be, see, lithium is electrons 3. So 1s2, 2s1. So first draw the diagram. See, lithium, energy here, lithium 1 atom, lithium another atom. So this is lithium 1s2. See, this is lithium 2s1. See, lithium 1s2, lithium 2s1. Right? Now let's mix them. Let's allow them to mix. So as they mix, we get sigma star. As they mix, we get pi star, sigma. This is sigma 1s. This is sigma 1s star. This one is pi sigma star 2s. This one is sigma 2s. See? So let's fill it up. 2 and 2, 4. So 2 up and 2 down. I mean 2 down and 2 up. 1 plus 1, 2. So 2 down. What do you see here? You can clearly see that this electron is bonding. This is bonding. And this guy in yellow is anti-bonding. So what would be the bond order? So bond order will clearly be, Nb minus Na by 2. So the one which is in red is the bonding electrons. So that will be 4 and this will be 2. So 4 minus 2 by 2, 1. So bond order is 1. Now how about lithium plus 1? So if you want to do lithium plus 1, just remove one electron. Make this empty. See, make this empty. So you just have one electron here. So one electron present in BMO. See? And what if you have to do for what you have to do for lithium 2 minus. How to do that? So let me use this thing in the, yeah, let me draw it for Li2 minus now. Then you'll understand how it can be done. See, I told you the shortcut, but anyways, you can try. So this will have 2 electrons. So 2 plus 1, 3. So see, there's an electron present in AVMO in case of Li2 minus. That's why the answer is Li2 more than Li2 plus more than Li2 minus. So you can use this to solve question. This is the order of stability. And that's how we can do it in less time. That's a general rule. Again, it's quite informal, but you can use this, neutral, positive charge, negative charge. Because if it is negative charge, there's a chance that there could be electrons in the higher energy shell or orbital. So I hope you got it. Now, the next topic that I've listed down was magnetic behavior. Very, very, very important. There goes no exam in an year where this question is not asked. There will be one of the exam that will be either in CET, states, JEEs, or NEET or JEE, whatever you write. There will be definitely one question from this topic, which is magnetic behavior. Magnetic behavior. And today I'm going to tell you a very, very interesting shortcut using which you can do any question that comes in your way. Very easy. See, what is paramagnetic behavior? What is paramagnetism? There are two kinds of behavior we have in our syllabus: paramagnetism and diamagnetism. Para means it is the property in which substances are attracted. Paramagnetic are the substances. There's a property in which substances, it is the property in which the substances gets weakly, not daily weakly, not that weakly, very weakly attracted by the magnetic field. As simple as that. So suppose you put something and it is weakly attracted by the magnetic field. Then the substance is said to be, yes, you are correct, paramagnetic. How do you understand that a substance is paramagnetic? Just check two things. If the species contain odd number of electron, then it's definitely going to be paramagnetic because it contains unpaired electron. If a species contains odd number of electron or it contains unpaired electron, it will be paramagnetic. This is one thing to look out for. Whenever you get a question, just try to count their total number of electrons. If the total number of electrons comes out to be an odd number, then definitely it is going to be paramagnetic. Else, exception. There is an exception that you must know, except 10. If total number of electrons, if total number of electrons comes out to be 10 or 16, despite having even number, they are paramagnetic. And why? It is because of their MOT diagram. So for now, we don't have to go that far into the concept. Just remember, if total number of electrons is 10 or 16, it's going to be paramagnetic, despite having even number of electrons. That's it. This is the second logic you have to look out for. First, count the total number of electron. If it comes out to be odd, para. But if it is even and it is 10, 16, para. How about diamagnetic substances? How about diamagnetic substances? So diamagnetic substances are the ones which gets repelled. They are weakly repelled by the magnetic field. They are weakly repelled by the magnetic field, which changes the game. So they are weakly repelled by the magnetic field. So how do we know they are going to be repelled? Because they have no unpaired electrons in them. They have no unpaired electrons. So if a molecule that is even number of electrons, molecules are species with species with even number of electrons. That's it. Use this shortcut. You can do any problems based on this. It should not be a problem. So for magnetic behavior, how to check magnetic behavior? There could be either paramagnetism, which is checked by, yes, you're absolutely correct. It is checked by this shortcut. Use this. If a molecule contains odd number of electrons or it contains unpaired electron, the substance will definitely be paramagnetic in nature. Exception 10 and 16. But if the molecule is diamagnetic, it will definitely contain even number of electrons. Because it has no unpaired electrons present, it will be diamagnetic. It will be weakly paired by the magnetic field. That's it. So with this, I'm pretty sure you can do any questions based on whatever it comes based on MOT using comparing stabilities and these kind of questions, where we have to find the paramagnetism paramagnetic behavior. Like for example, I'll just give you one or two questions on this. Find the magnetic behavior. Find the magnetic behavior. First one, C2 2 minus. Second one, N2 2 minus. Third one, N2 plus 1. Suppose the question is asked, you have to tell whether which of the following is paramagnetic, which one is not. Or paramagnetic. How to do it? See, C2 2 minus. How many electrons are there? Carbon has 6 electrons. One atom of carbon has 6 electrons. There are 2 of them plus 2, which gives you a total of 14 electrons. Is it even? Yes. So is it 16 or 10? No. It will be diamagnetic. That's it. Simple. Finished. Next, N2 2 minus. How many electrons? 7 into 2. Yeah. 2 electrons are being gained. So 7 into 14, 14 plus 2, 16. Is it even? Yes. But is it 16? Yes. So it's even, but it is 16 electrons. What will be the answer? Very good, guys. It's going to be paramagnetic. See? Simple. This is how we do it. N2 plus. N2 has how many electrons? 14. 1 electron gone. See? Cation. So 13 electrons. Is it odd? Yes. So is it paramagnetic? Most definitely. So that is how we can do any question based on magnetic behavior. So I hope this session is useful and you learned a lot about comparing higher order bond order questions. For simple questions, as I told you, you can go in the description below. I'll be linking it. I'll put the link for the other video. So first watch that and then come and watch this video. It will be much more helpful. And then after that, I told you how to do magnetic behavior questions. It's very easy. So in the next attempt, we'll be learning, next lecture, we'll be learning about how to do we'll be learning the shortcuts of finding structure and shape of, because it is the most important topic and most people have seen get confused in this part. So I'm going to share the shortest way possible to find the molecular structure and shape and hybridization. So you don't spend time on that in your JEE or NEET or whatever exams you are writing. So that would be the next following video. So please stay tuned to my channel for such amazing content. So if you had a wonderful session and you learned something new, please share my video to your friends and like this video and subscribe my channel. So thank you so much, guys.